This conference will now be recorded.
So hi, in this video, let me talk about Spark. This is the major tool in a big data environment to do your data science and analytics activities and the big data, which is generating enormously across the globe by every company, every individual. So now the latest Spark version is Spark 3.0. So let us try to understand Spark in detail, right? So here Spark is developed in 2009 in US Berkeley University in AMP lab, and they made it as an open source in 2010. Now it has become a top project in Apache Software Foundation company. It is mainly getting promoted by Databricks. Databricks is a company. This is a data-based company where you have a Spark a framework being used widely to do your data science and data engineering activities. To say simple, what is Spark? Spark is a fast and general purpose cluster computation engine. Whenever we say cluster, it is a distributed environment where computations are distributed and do parallel computations, generate the results. The Spark is enabled to do parallel computations. So here we said fast. When compared to Hadoop MapReduce or any other technology, the Spark is 10 times faster than any other technology when you are running on hard disk. When you are running in memory, that means RAM, it is 100 times faster. See the fastness of the Spark framework, the power of Spark framework. How do we compare Spark with Hadoop? The Spark is having a programming component. It does not have any storage component. But when you say Hadoop, Hadoop has got two components. One is the storage, another the computation. The storage component we talk about HDFS. Computation component we talk about MapReduce. So the Spark does not have a storage. Spark is only a computation engine. That is the reason we are comparing with MapReduce. A Spark is 100 times faster than MapReduce. A MapReduce is only a batch processing system. That means no instant results. But Spark has instant results. That means it can generate instant results, a real-time analysis, real-time processing of the data. MapReduce stores data always on hard disk. Obviously, when you are doing a lot of input-output operations on a hard disk, it will be very slow. But when you compare to Spark, the Spark stores data in memory in RAM. So it is much faster when compared to MapReduce. The entire Hadoop framework is built with the Java language, but Spark framework built with Scala language. Scala is a new language, object plus functional oriented language. In some other video, we'll discuss about Scala. Don't worry. Let us also try to compare Spark and Hadoop in terms of execution engine. So as I told you, Apache Spark is in-memory data processing engine. Also, most of the machine learning algorithms are iterative because each iteration can improve the results. What does it mean? Machine learning algorithm means a code again. You write some code which can be understood by the machine. But what is iterative? In non-iterative environment, when you write a code, it executes, takes input, generate output once, show to the user. But in iterative world, when you submit, after writing algorithm and submit the algorithm keeps running again and again, multiple times, automatically till it generates the result, actual desired results to the user. So that is called iterative. So whenever you are running iterative algorithms on a hard disk, that will be definitely make it slow your engine. So that is the reason requires a random memory That's where you run all iterative machine learning algorithms. So Spark is enabled for in-memory computations. So it is best suitable for running machine learning algorithms. So see the Hadoop execution engine. Here a MapReduce program will access data from hard disk, then generate results on hard disk, again pass it on to another program, again on hard disk, again pass it on to another program, again on hard disk. Even end results also stored in hard disk. But when you compare to Spark, we have a choice of storing data on in-memory or on hard disk. That is your choice, your requirement. From transformation to transformation, you can choose where you want to store data. That is the flexibility we have in Spark execution engine. So what are the main features of a Spark? One of the major features is real-time data analytics, and which is a distributed computation environment, as discussed previously. It is highly fault tolerant and dynamic in nature, lazy evaluation. So we will be discussing each one of them in detail in further slides. So real-time processing, it is most demanded feature across the globe by almost all the projects and products. You must have seen real-time environments, real-time streaming. The best example, Amazon Prime, Netflix. There are many like that. Reusability, speed, advanced analytics, in-memory computing. Now, similar to Hadoop ecosystem, Spark has got its ecosystem. That means it has got multiple modules to do different activities. So what are those modules? So one of the major module, hardcore module, is Spark Core. The Spark Core is the main module which will take care of entire Spark framework. You also have a Spark streaming. You also have a Spark SQL, Spark Emblem, Spark graphics. But whenever you want to build any Spark application, you cannot build Spark alone. You require to have one API, one language. That language can be either Java or Scala or Python or R. But most popular languages are Scala, Python. These two are equally growing along with Spark. Spark with Python, we call it the Pyspark. Right? So you always build Spark with Python pipelines, Spark with Scala pipelines. We are going to see in future slides. So all these things put together is called Spark ecosystem. As I told you, Spark core engine mainly for business validations or to do or to build actual logic. But what for Spark SQL? Spark SQL is mainly to do the structured data processing. Where do you see structured data? In RDBMS. What are the RDBMS engines? In MySQL, DB2, Oracle, SQL Server. There are many RDBMS engines like this. So there you see structured data like columns and rows. Whenever you find structured data, you integrate with Spark SQL and pull data and do the transformations. Similarly, sometimes you will find live streams of data. Nowadays, you will see a lot of applications demanding live streams of data where you can see Spark streaming. Then we also have machine learning algorithms. Just now we discussed the Spark Emblem. We talk about Spark Emblem. Then graphical data, Spark graphics. Then Spark with R. So all these things put together called Spark ecosystem, right? So Spark core main responsibility is to do memory management, fault recovery, scheduling, and distributing of, also monitoring of jobs, Spark jobs within a cluster, right? The Spark SQL, as discussed, it can be integrated with any kind of relational database or any kind of structured database. Spark streaming, any kind of real-time applications, real-time streaming applications can be integrated with Spark streaming. Spark graphics, graphical data, like where you have a source and destination, where you want to calculate a price calculation to travel from one source to destination. So like Uber, Ola, these kind of applications, or Facebook network, LinkedIn network, or Twitter network. This kind of networks can be processed by using graphics. Emblem machine learning algorithms. We have different types of machine learning algorithms like linear regression, logistic regression, classification, cluster, recommendation, predictive analytics. So for all these things, Spark Emblem has a predefined machine learning libraries Based on the requirements, you choose those libraries and implement within this all these algorithms. Spark can be integrated with any kind of tool, any kind of microservices, any kind of databases. So microservices like a Kafka or Elasticsearch or Delta Lake, or we can also link or integrate with the database, Redis, MongoDB, Cassandra, HBase, NoSQL databases, HDFS, Hadoop distributed file system, PostgreSQL, and many more databases. You name it, which can be connected to Spark computation engine. Remember, once again, Spark does not have any storage at all. Spark has only a computation engine. It is a cluster computation engine, right? This is one of the simple example for real-time analytics. So here you can see a lot of microservices connected each other to achieve this real-time analytics, but the main core activities, core analytics will be performed by Spark. So you see here many apps connected to Kafka network. This Kafka is integrated with the Spark framework. Spark framework will generate results. Results are shown to dashboard. So that's where the users will be accessing it. Right. What are the Spark use cases? We understood what is the Spark, what are the features of Spark, what can be with Spark, and where exactly Spark can be used in real time, real world. So to do the real time big data analytics, that means real time event streams coming at the rate of millions of events per second. This kind of streaming you see in Twitter, Facebook, YouTube, there are many applications like that. So iterative machine learning algorithms, I have already explained about what is iterative. Fast data processing, then iterative processing, and near real-time processing. And Spark widely used in the finance industry, like financial systems, like in stock market or in banking systems or in insurance applications, right? In banking, insurance and banking, wherever is a financial industry, the main uses of Spark is to understand the social media profiles, understand the emails, understand the forums, chat scripts, call recordings, video recordings, many more like that, right? The main objective for analysis, analyzing these different data formats is to take right decisions. Like it can also be used to understand a credit risk assessment. So where you can target different customers to advertise. Not only that, you can also segregate your customers. So e-commerce, another major industry, e-commerce industry. This is where you can use like recommending your products, recommending different types of services, products to users. Most of the times you see these kind of recommendations, Amazon, Flipkart, and e-commerce website. Healthcare industry. So the Spark has changed, shaped the healthcare industry. Let me tell you one thing: with other tools and technologies, to do a lot of R&D in healthcare, understanding a patient data is taking months and years. With the Spark introduction, it is taking hours, days, understand even minutes and seconds. So that is the power of a Spark framework. Most of the healthcare systems are implementing with the Spark framework. So media and entertainment industry, this is the most demanded industry. The most of the people are on entertainment world, right? So most of the people expects the real-time streaming. The Spark is the very powerful for real-time streaming. That is the reason the media and entertainment industry also using Spark very widely. So travel industry, this is another major industry which is being the used Spark framework. Right. So after understanding the Spark usage, slowly we are getting into the Spark technical things. Like a Spark, before we getting into Spark architecture, let us try to understand Spark terminology. The Spark terminology is driver, executor, cluster manager, Spark session, Spark context, RDD, data frame, dataset, partitions. We'll be discussing all these things in detail. Right? Don't worry now. So this is a Spark runtime architecture where you see driver, where you see cluster manager, where you see executor. These are the main components. The driver will talk to your user programs with the help of Spark session object. And user program will be divided into multiple tasks and delegated to these executors to generate results and combine and show to the driver. All these driver executors and program applications are managed by cluster manager, right? So this is the basic hardcore Spark runtime architecture, right? So thank you very much. This is the basic introduction of our Spark framework. We understood what is Spark framework, what are the internals of Spark, what is the usage of Spark, what are the unique features of Spark, why Spark is more popular, and finally we understood the Spark architecture. In another video, so I'll be explaining about Spark complete technology. Thank you very much.